Okay, so I think yesterday we tried to look at two factor factorial interaction. We discussed this analysis, and finally we got to this place where we had this equation. Today we want to demonstrate this on a Minitab environment. So if you have your Minitab, let's open it and we see how. So I share my screen. Then um uh, all right, so let's open the Minitab. Yes, so we'll have this, right? Then on a normal thing we do, right? We go to start, come to start, then we go to DOE, then we come to factorial design, then we create a factorial. From the question we discussed yesterday, there's a two-level factor. So we choose two level. Yeah. Then the factors, we have factors here, so factors should also be. And then you can click on design to see. Here we didn't touch anything here yet. Later we'll come and touch on these things. Then come to factors. Yeah, come to factors. If by default, it will name the factors A and then B. So we have to change it. So for my experiment, we have milk here, right? Milk. And then we have then we have two factors, a two level, so it's going to be low, high. You can change this if you want to use text. You can change it and then you put. For now, we just maintain the numeric. Then you click OK. When you are done, OK. Then our factorial design will come here. You can see it here. Let me move this on. You can see it clear, right? Then we'll have our rating. Our rate. For the rating, we have to go back. I think positive was 8.8, right? Then negative was 3.7. Then we have let's go to the fighters. Positive milk, negative sugar is 7.2. Positive milk, 7 point. Then the negative milk, positive sugar is 7 point. All right, so we have this. Remember, this is the standard order. Sorry, this is a randomized order. This is the normal experimental label it runs. So you have the first, second, third. But in this, we'll run the first experiment last. The third experiment will be run first. Second experiment will be conducted second. The fourth experiment will be conducted third. Okay. So when you have this, go back to start. Then we'll now analyze the factorial. Want to analyze factorial design like this. Then we will now assign our response variable. In this study, our response variable is the rating. So we check it and then we select the rating. For now, we'll not be doing any covariate analysis and stepwise and those things. So we'll leave everything as it is. Then you click OK. When you click OK, the factorial design will be analyzed. So you can see these are the results for the analysis. I'll find time and show you a lot of things here. But now we are interested in the plots. So you have this, now we'll leave that. Then you come to the equation. Now look at the equation we have here. We have the rating to be equal to 6.9 as 1.1 milk, 1.45 sugar, minus 0.64 milk. Is that what we have? Let's see. See what we had? Same, right? 6.9 plus 1.45 plus 1.1 milk minus 0.65 sugar times milk. So you see that we are having this equation. Yeah. All right. Then the next thing we did yesterday was to plot the main effect plot and then the interaction plot. So we will try to plot that here. In order to do this, we will go back to parts. We'll go to ANOVA. Sorry, we'll go back to DOE.
Recording in progress.
Go back to DOE. Then we'll go to factorial. When we go to factorial, we now have access to what's factorial. Eric Archery. Erickson. Erickson. Hello, Erickson. Erickson Archery. Erickson. Hey there. Erickson. Hello, Erickson. Ericsson Autry. Yeah. All right, I think he left. So maybe when he comes. All right. So we want to get our plots. We go back to the stats, DOE, we come to factorial, then we choose factorial plots. So when you come, these are the selected plots. You can add or take some out. For example, if I check this, if I want to remove this, I can just take it out. Means these are the available plots, variables we can plot their effects, but you decide which one you want to add, which one you want to. So if I want to add this, I just bring it back here. Then here you can decide to display all terms or only model terms. You can also choose all terms. Then you click OK. So when you click OK, this is now the main effect plot. If you remember yesterday, we had the main effect plots. So this is milk, and then this is for sugar. For milk, we had this to be 5.8, and then this one was 8, if you remember. Then we had one for 8.35, and then I think 3 point some 5.45 years. So we can see. And when you look at it, you can see that the effect of the milk stretched longer compared to the effect of effect of the sugar stretched longer than the effect of the milk, which sometimes tells you how much sugar is more related to the taste based on the people who tested it. Please take note. Based on those who tasted it, they like sugar, in fact, more than milk. That's one thing I can. They like a little bit of sugar in their tea compared to milk. Try to say that tea should be more of the determining factor of the sweetness of the compared to milk. Though it's not too much, but in the length, it is like. All right. And the next one is the interaction. So this is a clear interaction plot. So yesterday, you can see this is sugar on milk, right? So you have milk here. Then this is for low sugar. This is for high sugar. And we can clearly see the difference we were talking about yesterday. If you look at the difference between this and this is high. So which means that when milk is low, you need more sugar to give the taste of your tea. And when milk is high, the amount of sugar you need not too much. You can plot the same for milk on sugar, like we saw it, and you can understand how these factors are interact. We also we also publish the fact that when you see the interaction plot slanted this way, it tells you that there is a possible interaction among variables. They can even overlap how the interaction is. You always have to account for the level of and then all right. The next one is the contour plot. We can plot that too. If we want to check the contour, we go back to stats, DOE, factorial, and then we go to contour. Then we choose the X and Y we want. So you can see that the contour plot we have here It's a little bit different from the one we had the first time. The one without the interaction, there were straight lines. But now you see that these are curves. And this tells you the taste of coffee. Different within it, where it gives you part of this region. These are, for example, if I'm here, I will need more amount of milk. And if I add more sugar, that those who tested will like it. Will say this coffee is sweet. If I'm here, this region, I can add more milk and then a little bit of sugar. You see, it's a region. So within this region, the taste will always be sweet. You can use analysis like this to save the what's the name cost, optimize your system very well. For example, I know that sugar is cheaper than milk. Why don't I buy more sugar? Then use small milk my system. You can make more money. So you can play around with it along this line. Yeah. Yeah. Any question? Do you have any question? Right. If you don't have any question, we'll take another example. Then we can continue to this. Before we do that, just take some 3 to 5 minutes exhortation. So I would like to invite Mamiya. Mamiya, are you around? Mamiya, hello. Yes, Mamiya.
Yes, Doc.
Yeah, give us 1 minute exhortation.
1 minute what?
Motivation.
Motivation to continue the studies.
Yes, exactly.
Okay. Um. So so as we are continuing our studies, we are to be reminded that there is a future that we are fighting for, and that is why we are all here. So everybody should push harder so that they can get the future that they want. So I'm done.
All right, thank you. I think we'll take another one for me. I hope. I nominate someone to also.
Doc, you said I should unmute someone.
Yes.
No. Oh, okay. Um. Chris.
All right, Bella, Chris. So,
Hello. So as Mami has said, we are fighting for a future. So she put in the hard work, the education, all the sweat, and everything necessary for us to achieve the greater goal. Because it's a bigger picture we all have. So we should push and strive harder for that. So all the best to everybody, and I believe in us all. So let's enjoy the class.
we are fighting for a future. Whenever I see, that's a nice one. Who else? I want one more person. At least 3 people. Maybe I'll choose this guy who was worrying me. What's his name? Erickson. Where's Erickson?
Oh, please, I'm here.
Talk to him. It looks like you wanted to say something, but we couldn't hear you earlier.
Oh, I was actually on the website. Sorry.
Yeah, so tell us now.
All right. So, my principles are three. That is the three D's. The first D is determination. The second D, desire, and the last D is discipline. No matter how life hits you, you have to remember that sad can also fly. Thank you.
Remember the 3 Ds by Mr. Erickson. Thank you. All right, so I think we can continue the class. Let's see what we do. Always remember the 3 Ds. Now, we're going to take another example, another interaction, so that we will try to appreciate it. And I'm also going to introduce you to there's this online platform where we are able to do experiment and then use it for POE analysis and then appreciate how parameters affect each other. So we can gather the data and then it the way this is done. But it's more like a catapult experiment. So this is how it is. Now, when you take this catapult experiment, usually, I think everyone here is familiar with a catapult. In the olden days, these things were very powerful because these were used for projectiles. And even now, these are things that have been metamorphosed into the modern day missile shooting and all those things. Remember, and you like watching for an adventure movie, you see that we used to have stone throwers. Those things, we were all using this principle. Not like how we were just throwing the catapult without following the principles of it. All right. Now, when you look at this catapult here, mostly it is controlled by 5 factors. And these 5 factors here is aimed to achieve the distance this stone can go. Okay, so this is the y variable, and these are all x variables that affect the distance of this catapult being able to throw a stone. First one you always have is what we call the firing angle. I'll open the catapult and then you see. When you follow this link, it's a free website where you can always use this to experiment. So some of the assignments and projects I'll be giving you, you might have to go there, the catapult yourself, and you gather the data and you use it for your plot. So you see variables like firing angle. The next one is release angle. Then we have what we call the cap elevation. Then we have the pin elevation. Then we have the bungee position. So we'll try and see how all these things work and how they move. Let me go to I'll explain it a little bit. Come back here. I'll go back to the video. So let's open the link. Now, when you open the link, this is what you see. This is how the catapult is positioned. So you see the catapult. Now you see all the 5 things we talked about. This is the release angle here. Firing angle is also here. Can you all see my screen?
Yes, Doc.
I think you should be. And we have the cap elevation. Then we have the pin elevation, the bungee position. Let's look at them one by one. This one here, you see, this is what we call the cap elevation. Okay. This is the pin elevation. This is the bungee position. This one, where you shoot from. Then here is the firing angle. Okay, this is the firing angle. And this last one is what we call the release angle. Okay, Now, if you want to throw this catapult later, you see when you click on this, you can change the pin elevation. So the pin elevation ranges from 100 to 200. You can change the pin elevation and it will affect the catapult. Then you can also change this bungee position. I think it's, you can change it. Okay, so I can change it from, it also starts from 100 to 300. So you can move it around anyhow you like. Then you can change this, which we call the firing angle. If I click on this, I can change the firing angle. So it starts from 140 to 90. So it's 90 to 140 for the firing angle. And the last one is this. You can change where the position of the cap. So you see, the position of the cap starts from 200 to 300. You can always change that one. So for example, if I'm done and I want to fire, I'll click this. I just click on this and I'll push it down. So you see that the firing angle also starts from, depending on the position of the release angle. Sorry, depending on the position of firing angle, you can change the release angle to what you want. Then you shoot. So when you position the release, you leave it couple. Once it's shot, and it measures the distance for you. So it means you've been able to conduct one experiment. Then you take this measured length. Then you can come fire again, change to the next angle, fire another one. Then you measure that one too. Come again, fire again, choose one. Then you fire another one. You measure, conduct the next experiment, depending on the factorial you are dealing with and the number of levels you are dealing with. This is similar to maybe it could have been a plant you are trying to generate data and run for, but later I'll give you chemical related data. Why the knowledge. It's another one. Yeah. Then you keep going on and on and on. Okay. Right. So now for the experiment we have, we'll try and run this and then rerun again and see how our results will be like. We want to run for this scenario, but to make sure that our system is quite simple for now, because we are dealing with two-level, two-factor, we'll try to keep other three parameters constant. So the bungee distance, the cap, and then the other one is the pin. We'll try to keep them constant as default. Then we'll only vary the firing angle and then the release angle. And because we are looking at two levels, the first factor which we have is the firing angle. We want to use two levels of 100 and then 120. You get it? This one you see 90 to 140 here is just the range on the catapult. The range. But for our experiment, we want to maintain it at 100 and then 120 for the firing angle, and then 140 and 160 for the release angle. So this is similar to what we did. And when we conducted this experiment, we used this sequence. The first one was we fired at 120 degrees and then we released at 140. And we had this distance, 225. Second one, fired at 100 degrees, released at 140. Then we had 264. The third experiment, fired at 120, released at 160, and we had 432. Then the fourth one, fired at 100, released at 160, and then we had 373. So we want to conduct this experiment on Minitab and how our results is going to be like. So the same way, we can go to our Minitab, then we can start a new project. And let's see. Okay, we have a new project here. See what we can do. Normally, we'll come to start again. Go to DOE, factorial. We'll create a factorial. We still have a two-level and a two-factor factorial in this case. So we define the factorial in this, and we select our factors. The first factor is firing angle, right? Next one is the release. Okay. Then we click OK. Then we leave the rest. We create our experiment. So you see this is our experiment. Then our interest is distance. This time not rating, is distance. So the first one is, you remember from our experiment with you, we had firing angle 100, 140. That's the minus. We have 264. I'll put here 264. Next one is minus firing angle, positive release angle. We had 373. 373. Next one, we have plus minus 225. And the next one we had 4. Okay, so we are done conducting the experiment. Keep note, we'll use this firing angle a lot. So the next thing is to analyze this. What do? You go back to start, come to DOE, well, then we analyze. We're analyzing for distance, so click OK. And this is our experimental results. You see the regression here. This time it's telling us that if we want to predict the distance, we need this minus this and this. The interaction, yes, there is an interaction about 24.5. The interaction factor is also high. We appreciate it if we plot our normal plots. Let's go plot them and see. So we go back to stats, come back to DOE, go to factorial plots. And we want, that's what we have here. So we can see now the difference. You see that the firing angle has so much effect, right? It's quite steep compared to the release angle on the firing. That's how you can appreciate. Based on this, we know that there is going to be interaction. So let's see how the interaction is. This is the interaction. You can see that the interaction coincides. Look at here. If I come to the middle here, it means that between the two lines, in a way, the effect of either of them is kind of almost the same. See, they intersect here. But when this is high, when firing angle is high, the effect has a certain gap, a distance. Here, when firing angle is, the effect of release angle is also, so you can appreciate effects, how they what the interaction. We can go further and check for the contour plots. So we come here, factorial, we go to contour plots. Okay. This is the contour plot. Oh, this one. You can see that they are not so much straight lines, but you'll be able to target and hit good points. Yeah. So that's how this 2 level 2 factorial and over ifs. I don't know if you have any question on this. So I'll share this handout with you just right now. And then you guys should go through this website and get familiar with this. So next week, when we meet, we will go straight forward to what we call, I'll just give you a brief explanation to types of noise, uh, noise factors. Now start dealing with noise because that's what we're now going to talk about the blocking we talked about earlier. Remember when we ran the DOA, they have a place to state the number of blocks. We now talk about blocking, the meaning of blocking, talk about the complements, about randomization, about routines, and we'll conduct more experiments and then I'll use those that you get good results. So, do you have any question now? Okay. If you don't have any question, have Nathaniel Aqua to give us the last motivational speech. Nathaniel, over to you.
Hello, Doc.
Yes, my brother.
Doc, please, you said I should give what?
You give us the last motivation.
Motivations. Oh, okay. So, from what we've learned so far, we've seen that running experiments can help us determine information about everything around us. So, in our lives, we can use all these kind of information to influence the decisions we make. So as we continue on our daily activities, as we continue to live our lives, we should make sure that everything that we do, we consider it as an experiment where we can get data and influence the decisions in our life to make the best outputs and to become the best of ourselves. Thank you.
Thank you. So you want us to go around experimenting things, eh? Yeah.
Why not?
Okay. When you are giving money, try and experiment it on me. All right then, guys. Have a nice day. And we'll meet. Bye.